Sorry, I accidentally cut the video short. My thumb had hit my my volume button, which stopped the video. So let's just go back where we left off from. So this is question 1.3 for exam 27. So we're going to continue where we left off. We're just going to plug in these values. We rearranged the equation to solve for the magnetic field. So we have negative F, so negative times 10 to the negative 15th divided by the charge, negative 19, all divided by, you could do keep change flip, I'm just going to leave it all as is and plug it in the calculator, by 3.75 times 10 to the 5th, but it's going to be negative from this transformation we just saw before. So negative 3.75 times 10 to the 5th. That should give us our answer. Actually, well, since we know that these are both negatives, we can just cancel those out. That's going to end up being a positive value. So 2.1. 3.2. This guy in parentheses just to be sure. Divided by and that gives us 0.0175, or we can just say 1.75 times 10 to this negative second. So B is 1.75 times 10 to the negative second T here. Excuse me. And part E is asking us to find the direction of B. And yeah, so as we said before, it's going to be in the, these are canceling, so this is going to be B for Z in the positive Z direction. So I'll just tack it on in positive Z. We were just able to make that observation throughout doing the math for the problem itself. So this is for part D and E. Last question, 1.4. Has two parts. So it says a highly ionized iron atom, or highly ionized iron atoms are found in the sun, yada, yada, yada. So lost 13 electrons, so plus 13E. So our charge is given as positive 2.08 times 10 to the negative 18th coulombs. Experiences a magnetic force equal to 2.3 times 10 to the negative 15th, I think they said. Yeah, times 10 to the negative 15th newtons. Does it give us when it moves at a velocity of 7.3 times 10 to the 3rd meters per second in the XZ plane, 36.9 degrees from the x-axis. So I'll just write it right beneath here. 36.9 from positive x, and 53, again to sum to 90 degrees, 53.1 degrees from the positive Z axis. And the question is asking us to find the magnitude of the magnetic field. So I kind of want to draw this one out really quick. So it says it's going to be on the it moves at a velocity in the xz plane. So if we say z, x, y, we can treat this guy as the xz plane, and it is going, let's write like this. Should pretend it's like on that plane. And then we have from the x-axis is that, I'll just say alpha value, and then from the z-axis that gamma value. So that is alpha, and that guy is gamma. And then obviously this is the velocity vector on that plane. So we could decompose it right here, or we could do it as we're solving the problem. I kind of want to obviously take this visual, but then kind of plug it in as we're solving the problem. So we are looking for, wait, let's see. Does it say magnetic force, experience magnetic force when it's moving XZ plane? Okay, so dB respectively. Okay, yeah, so we're able to say this guy, y hat, from the information we're given from the problem. And okay, yeah, so we're looking for, let's see here, so we're looking for B. So again, we're going to use the similar equation that we've been using before. So I'll just denote the direction that all these guys are going in. Q times the cross product between V and B. And we're looking for the magnitude of the magnetic field. So we want to make sure we're using the, let's see, the correct bits of information here. So, okay, so I forgot to write this down. I was wondering that. So the magnetic field is only in the positive z direction. So I'll just draw a little dotted line going up. So I'll just say B positive z hat. So that's important to note. So it can only be going in the z direction. So we can we can compose this equation as the force equals the charge times the cross product, and we know V times yeah, so V has the two components, and it has to match up with Z, so we'll note that. So V, and then I'll just do a little bracket here, V times, again, this is what I was saying, we could decompose it right there, or we can do it as we're solving it. So for this alpha, or this, like, with respect to the x-axis, which is 36.9, we would say V times cosine of that angle. So V times, and I'm just going to leave it the velocity factored out of this. So I can say essentially it's V times this cosine of 36.9, and that is for the x hat, so for the x direction. And then we would say plus, because it has two components, the vector has two components here, plus, and we just do the opposite, so sine of the gamma angle 53.1, and that is for positive z, close the brackets, times b. So so here we have x and z for the velocity, so it's going in two different, it has two components here, but we are, if we were to, so if we were to multiply the v in there, and then we were to do the cross product, since b is in, I forgot to write that, the magnetic field is only as a positive z, if we were to do z with the cross product of itself, that would just be 0. So this essentially, that sine of 53.1 essentially goes away. So that's, I'll just do a little arrow, equals 0 if we were to do the cross product out and factor all this out and then try to plug everything in at the end. But we can save ourselves some time from just realizing that the cross product between z and z is going to be 0. So essentially we are left with the magnetic force equal to the charge times the velocity of, the velocity times cosine of that angle on the x-axis times our B value. We're still looking for magnetic field. So from this we can, let's see, how do we want to do this? We can take the, so let's just do this. So let's say now we have B in the coordinates we want, so we can do B equals, and then F divided by this guy right here. So 2.08 V, yep. So, and then we're gonna have F divided by this guy. So our F is 2.3, 10 to the negative fifth, or 15th, sorry. And that's in the Y. Divided by the charge, which doesn't have a direction, of negative 18, yes, negative 18, times, and then that guy. So V is 7.3 times 10 to the third times cosine of the alpha angle, 36.9. And this is in the X direction. Yes, so let's do that out. That's going to give us 0.894, etc. Let's just do, for most cases, we've had the charge in, yes, let's just do 3. So let's just say 189T, and based on the directions of both of these, because the next part for part G is asking for which direction, so I'll not jump the gun, and I'll say in the negative Y direction. And that is for parts F and G. And that wraps up, let me see if I can get there we go. That wraps up all of the work for exam 27.